What's up, everybody? I'm 91Pickles, and today I want to be telling you about high mass stars. Now, what's a star? You may be wondering. I used to ask myself that all the time. But stars are celestial bodies of gas and dust, and there's a little bit of elements in there, hydrogen and helium.
Hi, I'm Randy Saxophone, and you might be wondering how the life of a high mass star goes about. So it all starts with the planetary nebula, and this is a great representation of what the planetary nebula is. So it's a giant cloud of dust and gas, mostly made up of hydrogen and helium, and can be tens to hundreds of light years across. It can be like about 10,000 degrees Celsius. And as the gravity pulls all the gas together, it starts to form this ball. This thing. This is a main sequence star. And as the dust and gas comes together, this core gets denser and denser, hotter and hotter, starting nuclear fusion. Nuclear fusion is the process of combining these hydrogen atoms to create heavier elements like helium, carbon, etc.
This is what a main sequence star is. It lasts around 10 million years and can be up to 50,000 degrees Celsius. What? They're 7 to 200 times bigger than our sun, which is pretty darn big, if you ask me. They're mainly made up of hydrogen and helium, and there's a little bit of gas, some dust, space dust, and some other elements. Once this thing stops fusing hydrogen into helium in its core, it turns into what we call a red supergiant.
But this is a supergiant. So once a main sequence star fuses all the hydrogen in its core, it starts fusing the helium to create heavier elements, such as carbon and oxygen, and all sorts of things. So these typically last a few 100,000 years and are 2,200 to 3,200 degrees Celsius. What? And are always red and usually 100 to 1,000 times larger than the sun. So once nuclear fusion happens and there's only iron in its core, this thing explodes violently.
Supernovas, what are they? Well, it's pretty much how a star mass dies. High mass star dies. It dies with an explosion, and that explosion can cause the core of the star to collapse within less than a second. And the shockwave of the explosion takes a few hours to reach the surface of the star. The size of the explosion depends on the actual size of the star, and the color ranges from blue to red. It can also reach up to 1 million degrees Celsius. Now that is hot, and I've seen your mother. Anyways, these stars, the explosion causes the iron in the core to fuse into heavier elements, such as gold. And after the supernova, these things can turn into black holes. Black holes. How are they formed? Black holes are formed when a red supergiant, whose core has a mass 2.8 times greater than our sun's core mass, goes through a supernova. What? These black holes suck everything. You cannot escape a black hole. Not even light. Not even light. And you know how fast light is? No. Their length, they last a very, very long time. Take the number 1 and put 100 zeros behind it. That is how many years it takes to shrink and disintegrate. Their temperature is absolute zero. Negative 273.15 degrees Celsius. There is no specific size for a black hole, as the size of a black hole varies depending on the actual size of the star itself. The color? Black. Elemental composition? There is no element in a black hole. There is a single element in a black hole. It's just torn apart and compressed. Now, how do these monstrous, sucking behemoths die? That's a good question. the gravity becomes so strong that not even a black hole can handle it, and it ends up shrinking it into a singularity.
Huh?
And this is the story of a black hole.
Water, ice, salt, ayy. Water, ice, salt, ayy. Water, ice, salt.
Now, once a supergiant supernovas with a core that is about 1.4 to 2.8 times that of the sun's core, then it turns into this neutron star. These typically last about 100 billion years, and they can be really, really hot, 1.8 million degrees Fahrenheit. Now, what's crazy about this is that its diameter is only 12.5 miles, and the gravitational pull is 2 billion times the amount of the Earth's. And that's only in 12.5 miles. Imagine how dense this is. Denser than Levant. Now, the color of this is white. And what this is made up of is entirely of neutrons.
Those high mass stars. I'm 91Pickles, signing off.
From the bottom to the top, my lifestyle.